Next we have question number 11 with us. Here we need to find the value of R if we have got three subdivisions. Let's try to solve these questions one by one. Okay. Coming to the first subdivision, here we have to find the value of R if 5PR is equal to 2 into 6PR minus 1. So remember the definition of NPR, because here they are using the NPR's notations here. So that means we need to be very clear about the notations. Okay. And also we should be very clear enough about the values. Okay. Whenever we have this NPR, definitely this N value will be greater than or equal to R. That we have to remember. In that way we have to see to find and then get the values of R. Okay. Alright. Yes. And also we will try to solve these questions in a more elegant way. Okay. Without any complications. We'll try to solve using simple steps. Alright. Okay. Yes. Starting from the first subdivision. 5PR. Let's use the definition of NPR. It's going to be what? N factorial by N minus R the whole factorial. Is it or not? So that means 5PR can be written as what? 5 factorial divided by, here we have denominator 5 minus R the whole factorial is equal to, coming here right hand side we have 2 into, so 2 into 6PR minus 1. So 6 factorial divided by, what about the denominator here? What will come here? Here we will have 6 minus of R minus 1 the whole factorial. Okay, I hope you can understand that. Okay, maybe if you want I can just use this rough space to just show the simplification. So what we will have in the denominator is, we will have 6 minus R minus 1 the whole factorial. The whole factorial will come. Okay, first of all we will just see what will happen for this expression. So this can be written as 6 minus R plus 1. Is it or not? Because when you take the minus inside, this becomes 6 minus R. Then minus of minus 1 will become plus 1. So 6 minus R plus 1. So that means we will overall have what? This will become 7 minus R. Okay. So you will have 7 minus R the whole factorial. This is what we will be having. Yeah, fine. Yes. And again, we will try to rewrite our terms in terms of the other factorial numbers. Okay, fine. Yes. So left hand side we will keep it as it is. 5 factorial by 5 minus R the whole factorial is equal to right hand side. Okay, come to the right hand side. Right hand side we have 2 into this 6 factorial. I am going to rewrite as 6 into 5 factorial. We can use the properties of factorial, right? So when you try to do that, this becomes like this, 6 into 5 factorial divided by, same way come to this 7 minus R the whole factorial. This can be rewritten as 7 minus R into 6 minus R into 5 minus R the whole factorial. I hope you understood the reason why we are doing this. Why? Because I am trying to rewrite this 6 factorial in terms of this 5 factorial and this 7 minus R factorial in terms of this 5 minus R factorial. That is my objective. Okay. So once we are writing like this, now we can very easily cut this 5 factorial with this 5 factorial. This 5 minus R factorial with this 5 minus R factorial. Okay, I mean the whole factorial. Okay, yes, fine. Now you can take these terms to the left hand side. So what happens is you will simply get 7 minus R into 6 minus R is equal to, right hand side we will be having simply 2 6 are 12. Okay, all right, yes, yeah, fine. And now no need to expand it or multiply it, distribute it, expand it, get a quadratic equation and then go for that. Why? Because this step is allowing us to get some, do some it is some advantageous for us. Why? Because you see these values here. This is 7 minus R and this is 6 minus R. What can I tell about these two values? This is 7 minus R. It is going to be some number. As of now, we don't know about it. But what about the 6 minus R? We can tell this 6 minus R will be nothing but 1 less than this 7 minus R. So that means, very simply, if I want to tell, very simply, these two are two consecutive numbers. This is a number and this number is 1 less than that. That's it. Very simple. Okay. So 7 minus R is going to be some value and 6 minus R is going to be a value which is going to be exactly 1 less than the 7 minus R. I hope you can understand this. Why? Because from 7 minus R, if you do minus 1, you will be getting the 6 minus R. Is it or not? Now let us try doing our right hand side, or we will try to rewrite our right hand side also in the same way, in a similar way. Okay. We'll try to write this 12 as the product of two consecutive numbers. Okay, fine. Yes. So we will rewrite this 12 as, in what way we can rewrite? I hope it won't be that much difficult for you to think and get it. Fine. Yes. This 12 can be very easily rewritten as what? We can easily factorize the 12, right? So how can we rewrite it as product of two consecutive numbers? Very simple. 4 3s are. We can rewrite this as 4 3s are. Now we can very easily get the value of R. How we can get is, Very simple. Now we can compare this 7 minus r with this 4 or this 6 minus r with this 3. Fine, okay. Anyways, you get it, you will be getting the same value. Why? Because just now we saw the reason. Is it or not? See here, we can just write these two terms, okay. These two numbers represent these two values only. That is how we just factorize this 12 itself. Is it or not? So in that case, in that sense, what we can simply do is I will compare this 7 minus r with this 4, okay. So once I do it, what I will get? 7 minus r is equal to 4, which will give us r is equal to 7 minus 4, which will be 3 is going to be the answer. Or otherwise, even if you compare 6 minus r with 3, that is 6 minus r is equal to 3, even if you try to solve that, you will again get the same value, r is equal to 3. In that case also, you will get the same value for r, okay. So anyways, r is equal to 3 is going to be the answer for this question, okay. Yes, so the only point we have to keep in our mind is, see these two expressions, they represent two consecutive numbers, that's it, okay. The bigger one into one less than the smaller one, that's it. So the same way I am trying to read this 12 also in that way, and that is allowing me to get the answer in a very easy way. That's it, very simple, okay. So anyways, r equal to 3, that's going to be the answer for your first subdivision. And coming to the second subdivision, here we have p of 11 comma r, which is nothing but 11pr, that's it, okay. So 11pr, so how can you write 11pr? 11pr can be rewritten as 11 factorial divided by 11 minus r factorial. Yes, fine, yeah, okay. This is equal to, now right hand side we have what is p of 12 comma r minus 1, okay. This is what we have. So this means this is 12p r minus 1. So that means 12 factorial divided by what we will have in the denominator. Maybe I can use this rough space to just calculate it. So you will have 12 minus r minus 1 the whole factorial. Is it or not? Because this is like npr. In the place of n we have 12, and in the place of r we have r minus 1. So we will have n minus r the whole factorial, which is what is this 12 minus r minus 1 the whole factorial, okay. Now when you expand this, you will be getting what? 12 minus r plus 1, which is in turn what? 13 minus r factorial. So 13 minus r the whole factorial. This is what we will be getting. Yeah, yes. So once you understood this, I don't feel that this, for you to understand this one, it will be very hard for you to understand. You can easily catch this. Yes. Okay. Yes. Again, as usual, I will leave the left hand side as it is. Okay. I am not doing any editing process in your left hand side. And here, right hand side, we can write it as 12 factorial can be rewritten as 12 into 11 factorial divided by. Now, what about this one? 13 minus r factorial. This also I can rewrite it as 13 minus r into 12 minus r into 11 minus r the whole factorial. I hope you can understand like what steps, what approach we followed here. The same approach is what I'm handling here also, okay. Now I'm doing this so that I can cut this 11 factorial and 11 factorial. Denominator 11 minus r factorial and 11 minus r factorial. So we will be simply left with these two terms, okay. These two terms will go to the left hand side. It comes as 13 minus r into 12 minus r is equal to 12, simply 12. And here also the same thing happens. See here, we have got two expressions, 13 minus r and 12 minus r. Again, these two expressions, they stand for two consecutive numbers only. Why? Because here you have 13 minus r, is it or not? This 13 minus r, and from this number if you do one less, that is what is this 12 minus r, right? So which is equal to 12. That means here also this 12 can be rewritten in the same way, consecutive numbers, product of two consecutive numbers, like how we wrote 12 as 4 into 3. Same way here also I can write this 12 also as 4 into 3, okay. Because of the reason, what is the reason? These two expressions, they represent two consecutive numbers. For that reason, I am rewriting this 12 like this, okay. Yes, the bigger number and next the smaller number, which is one less than the bigger number. That's it, okay. Now as usual, I can compare this with 4 and this with 3, okay. If I do either way, I will be getting the same value for r. You can even check it. So I can compare this 13 minus r with this 4. So once I do it, I will be getting 13 minus r equal to 4. So r is equal to 13 minus 4, which will be equal to 9. Is it or not? Because 13 minus 4 you do, you will be getting r equal to 9 only, right? So r is equal to 9 is going to be the answer. And again, however, even if you compare 12 minus r is equal to 3, you will end up with the same value for r is equal to 9. Okay, alright, yes. So yeah, yes. And now coming to the third one, here we have to do this problem in a little careful way, okay. So here we have this problem based on ratios, we have this, okay. So since we have ratios, we have to remember the division process, alright. So here we have p of 15 comma r minus 1. So that can be rewritten as what? This can be written as you can use the NPR definition. Okay, if you use this, you will be getting 15 factorial divided by, what about this denominator portion? This can be what? This will be what? 15 minus of r minus 1 the whole factorial. Okay, I hope you can work it by this time. You would have worked it by this time. So 15 minus of r minus 1 will give you how much? Simple, 16 minus r the whole factorial. That's all. Okay, this one is to means you can use the division sign. Divided by, we have 16p r minus 1. What about 16p r minus 1? That will stand for 16 factorial divided by here denominator you will have 16 minus of r minus 1, which will be 17 minus r the whole factorial. So this will be equal to, right hand side we have 3 divided by 4, which means 3 by 4. That's it. I can write it as a fraction. And what next I can do is I will just write this one as 15 factorial by 16 minus r the whole factorial into, I can change the division sign as multiplication, and for which reason I will just take the reciprocal of the term. So if I do that, I will be getting 17 minus r factorial by 16 factorial is equal to 3 by 4. And once again what I can do here is I will have this expression as it is, 15 factorial by 16 minus r the whole factorial multiplied by, now we will try to rewrite these terms. Okay, this numerator 17 minus r factorial can be rewritten as 17 minus r into 16 minus r the whole factorial divided by this 16 factorial can be rewritten as 16 into 15 factorial. This is equal to 3 by 4. And now I can clearly cut this 16 minus r factorial, 16 minus r factorial, and this 15 factorial and this 15 factorial. Now we are simply left with 17 minus r by 16. Just listen carefully. A left hand side is, now all we have in our left hand side is 17 minus r by 16 is equal to right hand side 3 by 4. That's all we have. Okay, I think directly we can cross multiply. Is it or not? We can do it, right? So once I try to cross multiply, what happens is we can even directly, I can simply bring this 16 alone to the right hand side, right? So if I try to do it, I'll get 17 minus r. 17 minus r is equal to 3 by 4 into 16. We'll be getting this. And once this one, if we simplify, if you try to simplify this, you will be getting 4 and 16 exactly 4 times. So you will have 3 4s are 12. So you have 17 minus r is equal to 12. This is all you have here. And now if you continue this, when you solve for r, you will be getting r is equal to 17 minus 12, which will be equal to 5. So finally you got the value of r here also. So r is equal to 5, right? So not much complicated, but here we should be little careful, since this is involving the ratio concept, division, everything. You should be little careful with the algebraic process what we are doing here, undergoing here. Okay, only that part we should be clear, else if it is going to be an easy question only. Yes, okay. Now I hope you are clear about all these 3 subdivisions, how we are solving without going for much complicated steps. Okay, just by playing with numbers itself you are able to get the answers for these questions. So yes, these are going to be the answers for your question number 11. Next we have question number 12 with us. How many words can be formed using all the letters, and the two using each letter exactly once of the following words? Okay, so that is, with this given words, how many words we can form? That is, the question is asking about a very simple task. So given these words here, and using these words, using the letters of the words, in how many ways can we rearrange these letters in different possible ways, and we can form new words? This is what they are asking us to find. And that too, we need to use all the letters, and that too we have to use them exactly once without repetition. This is going to be the question. So we have got 3 subdivisions here, very easy questions, and let's try solving these questions one by one. Okay, if I show the idea for the first one, you can easily get the other 2 questions. Fine. Okay, coming to the first question, here the given word is Delhi. Okay, so D-E-L-H-I. So this is the word, and by looking itself we can easily tell there are how many letters here in the word. There are 5 letters available, right? So D-E-L-H-I, there are 5 letters. So 5 letters we have to rearrange, and also please check whether is there any letter repeated. Do you see any letters repeated here in this given word? No, there is no repetition at all. So that means all the 5 letters are distinct letters. So we need to arrange those 5 letters in 5 slots. That's it, right? So that means how many ways will be there? 5 letters in 5 slots. It's going to be simply 5 factorial. That's it. Okay. If at all, if you want to expand it, what comes? You will have each slot, first one 5 ways, second one 4 ways, third one 3 ways, 2 ways, 1 ways. This is going to be the expanded form, but still I'm just trying to write it in a very short way possible. So 5 factorial, that's it. Okay, so since we have 5 letters and all the 5 letters are distinct letters, 5 factorial is going to be the answer. Very simple. Okay, so 5 factorial. What is the value of 5 factorial? When you expand it and compute it, you will be getting the answer as 120. 120 is going to be the answer for your first question. And come to the second question. Here we have the word Jaipur, right? Okay, and Jaipur, how many letters are here? Here there are 6 letters, right? 1, 2, 3, 4, 5, 6. There are 6 letters here, and here again we don't have any letters repeated. So that means here how many ways you can have? So this will have 6 factorial ways. Okay, so 6 letters, all 6 are distinct letters. That's it, 6 factorial ways. So 6 factorial, the answer is going to be 720. And last one, third one, here we have the word hexagon. Okay, Hexagon. So there are 7 letters here, and again all the 7 letters are distinct. So an answer is going to be 7 factorial. So what's the answer for 7 factorial? So 7 factorial is 5040. That's going to be the answer. So very simple question. We got the answers very easily, provided if you are very clear about the factorial values, if you know them by heart, you can quickly answer these questions. Yeah, of course, these are going to be the answers for your question number 12. Moving to the next question, question number 13. Here we have 4 different mathematics books, 6 different physics books, and 2 different chemistry books. So see what are all the things we have. We have 4 maths books. All right, okay. So let us have those books to be maybe M1, M2, M3, M4. So these are going to be the 4 maths books. 6 different physics books. So we'll have them to be P1, P2, P3, P4, P5, P6, and 2 different chemistry books. So we'll have the 2 chemistry books to be C1, C2. Okay, I hope the notations are very easy for you to understand. Are to be arranged on a shelf. So totally how many books are here? So if you see, there are totally 4 plus 6 plus 2, 12 books are here available. So these 12 books are to be arranged on a shelf in a row. How many different arrangements are possible? If so, we have got 2 subdivisions. So of course, when we try to work these questions, concept wise it is going to be much easy, but calculation wise, if you see, we have more works to be done here. So be ready for your calculations. So yeah, the first subdivision says the books in each particular subject must all stand together. So what do you mean by that? So the first subdivision says each particular subject, books from each particular subject, it should be always together. So that means the maths books should be together among themselves. Physics books, all these 6 books, they should be together, and chemistry books, they should be together. Between 2 maths books, you should not have a physics books or chemistry book coming. Or between 2 physics books, any 2 physics books, you should not have a different subject book in between. This way we should not have. So each subject books, they should be always together. This is what they come to say here. Okay, so in that case, how we can handle this problem? We can handle it as M1, M2, M3, M4. This entire group, this becomes one single bunch. And here coming to the physics books, P1, P2, P3, P4, P5, P6. So this entire, this collection, this becomes one single bunch. And these chemistry books, they will become one single bunch. So that means we made how many bunches here? We made 3 bunches here. Is it okay? Fine, yes. So that means now if you try to move them wherever you take them, they all will come as a bunch. That's it. So that means here our objective is like arranging how many different objects? There are only 3 different objects now. Do you understand that? So if I see overall, what happens is, since we have the condition that each subject book should be always together. So what do you mean by that? That means we have got 3 collections only. There are only 3 objects here, 3 bunches, 3 objects are only here. So 1, 2, 3. So our task is just like we need to arrange only 3 different objects. That's it. Okay. So that means this can be written as what? 3 factorial. Because to arrange 3 objects, there are 3 factorial ways. Is it or not? So 3 factorial into, the problem is still not over. Why? Because what? Because we have the condition that the subject books should be together, but within themselves, I mean, if you take this max bunch, within this bunch, these 4 books can be in any different order, right? Correct? Yes. So that means for each of these 3 factorial arrangements, we have got how many here? This max book, when you take this max book bunch can be arranged within themselves in 4 factorial ways. Similarly, This physics can be arranged in 6 factorial ways, and similarly these 2 chemistry books in 2 factorial ways. I hope you can understand this. Fine, okay. You should be very clear with each of these factorial numbers why we are writing this. So let me just summarize. This 3 factorial is for these overall 3 bunches. I can arrange in any different order. And this 4 factorial is for within max 4 factorial arrangements. Within physics, this 6 factorial arrangements. Within chemistry, 2 factorial arrangements. Now when you work out all these things, you will be able to get the answer. Of course, this is going to be a very huge answer. So we'll have to work them carefully, right? So first of all, we'll just try to write the values here. So this will be 3 factorial will be nothing but it will be 6, right? So 6 into this 4 factorial is 24. This is 6 factorial 720, and this is 2 factorial, which is simply 2. So now we need to multiply all these numbers to get our overall final answer. So this will give you maybe this space we'll take it for workout. Okay, so we'll make some rough calculations here. Yes, so how we can start here is maybe I will multiply 624s are 144, 144 2s are 288, right? So 288 into 720, this is what we are supposed to do. So 288 into 720 is what we need to do. Maybe I will multiply 288 into 72 first, okay? Or I'll write 720, okay? Why to forget it? So 720, but when I multiply, I will just multiply it with 72 alone, okay? All right, yes. So now I'll just do my multiplication process. So this will give me like 6, 2 8s are 16, 1 again 16, 1 17, then 5. So 576, this is giving me 576, and next multiplying by 7. 7 8s are 56, 5 carry, again 7 8s are 56, 56 plus 5 will be 61, 6 carry, 7 2s are 14, right? 14 plus 6 will be 20. So 2016. So when I add overall, I will be getting, this is 6, this is 3 plus 1 is going to be 7, this is 0, this is 2. So attaching another 0. Why? Because we are multiplying by 720, right? So your overall answer will be 207. I'm sorry, I'll write it clearly, okay? So I'll write it clearly. Yes, 207360. This is going to be your overall answer for your first subdivision. Yes, okay, all right. I hope you are able to understand this properly. So these notations are very important, and again these calculations are even more important. Do it carefully. And yeah, coming to the second subdivision. So the mathematics books stand together. So second subdivision says, this one states a condition about only for the max books, okay? The max books stand together, okay? Same 12 books, but this time the max books should stand together. That means we have to collect only the max books in one bunch. So I'll write it once again, M1, M2, M3, M4. This will become one bunch, and there is no restriction for the other subject books, okay? So that means what are the other subject? There are other 2 subjects are there, and the books are going to be P1, P2, P3, P4, P5, P6, and chemistry C1, C2. That's it. So that means here we don't have any restriction. Like these books can be in any different order. Okay, fine, yes. But we have a condition that only these 4 max books should be together. Okay, all right. So in that case, don't make bunches here. They are all like individual books, but this max book collection will become one single bunch. Do you understand? I hope you're able to get the point, okay? So here, since here we don't have any restrictions, here alone the restriction is specified. We make this max book bunch, max book collection alone as one single bunch, okay? That means here our task is like arranging how many books? How many objects? Our task is like arranging how many objects here? So now we'll count and see. There will be totally 9 objects here, is it or not? Because here there are 6 plus 2, 8. Plus 1, this is like one single object now, okay? Just remember that very carefully. So now our task is like just arranging 9 objects, so for which we will be getting 9 factorial, but the problem is still not over. 9 factorial continued by, multiplied by. Now for each of those 9 factorial ways, we have what? We have these max books can be arranged within themselves in another 4 factorial ways. That's it. Do you understand this? I hope you can get this point, okay? So since here we have individual bunches, we arranged the bunches, then we got for I mean, like we went for this individual arrangements, but here we have overall 9 objects so far, which 9 factorial, and only the max is here, which can be arranged within themselves in 4 factorial ways. So I'm multiplying by 4 factorial. So 9 factorial into 4 factorial will give you the overall answer. But anyways, we have to compute it. That is what is even more important, right? So more than working the problem, these are going to be the big punishments given to us. So yes, anyways, we'll manage to do them. 9 factorial. First of all, we have to, we know this 4 factorial is just 24, right? So it's going to be into 24. But 9 factorial is going to be considerably a large number. So 9 factorial will be, basically 7 factorial is what? We know up to 7 factorial, which is 5040, right? So for 7 factorial is 5040, and we need to multiply into 8 into 9 with this, is it or not? So I will do into 8 first. Into 8 means we will be having 0, 32, and this will be 4 8s are 40, and one more into 9 we have to do. If I do into 9, this will become like 0, this is 9 2s are 18, 1 carry, again 9 3s are 27 plus 28, so we'll have 28, and 9 4s are 36. So we will have 362,880. This is going to be the value of 9 factorial, but this should be multiplied with 24. That will only give you the overall answer, is it or not? So if I want to multiply this value by 24, this into 24, what I can do here is, yeah, we can multiply by 24. Okay, yeah, let's do it carefully. So yes, I'll just as of now forget this 0. Okay, so I will multiply as if the 0 is not available here, and later then we will, with the final answer, we'll attach the 0. Okay, no issues. So now we will just multiply it. So we'll be having 4 8s are 32, so 3 carry, again 4 8s are 32 plus 3 will be 35, 3 carry, again 4 2s are is 8, 8 plus 3 will be 11, 1 carry, 4 6 are 24 plus 1 25, 2 carry, 4 3s are 12 plus 2 is 14, 1 4 5 1 5 2. This is what we are getting at the first step, right? Yes, please, you can also check it once. So let me also check it once, because I don't trust myself all the times. That's the reason. 32 3 carry, 35 3 carry, 11 1 carry, and then 25 4 is 24 plus 1 25 2 carry, and then 12, yes, 14. This is what we are getting. And once again, 2 into this one we are supposed to do. So when you do this 2 into, this will become like, we have to move one step ahead, right? So 576. So 576, I'm directly multiplying this into 2. So 576. And what next I can do is 2 into this one will be 72. Yes, 72. So this will give you 2. This is 11 1, this is 9, and this is 0 1, this is 7, and this is 9. So we get 970912. With the 0 we have to add. So our answer, overall answer, is going to be like 970. I mean, we have multiplied it already. Okay, so this is what is 362,880. With this, when you multiply 24, we will be getting our overall answer as 9709120. This is going to be the overall answer. I also feel, I'm sorry, because this is 8, right? I'm sorry, this is not 9, because this has to be 8 8 8 8. I'm sorry with that. So this will be 8709120. Anyways, we'll even cross check once. So 2 11 1 9, so this is 70, and this is 8. Yes, 870912 with a 0, because one 0 is attached here. That's the reason. That's why. Okay, fine. Yes, all right. So yeah, anyways, we successfully got the answers for both these subdivisions, and these are going to be the answers for your question number 13. Moving to question number 14, again a different variety of question we are going to work now. So here, if you see, we have got two subdivisions, and both of them are going to be of the same type. Okay, all right. Yes. So this is going to be of the type not together. Okay. We have already seen few questions based on the logic of together, how to arrange in such a way that these particular objects are always together. But here, if you see this question number 14, here we deal with a different variety of arrangement, like the object should not be together. That way we are going to see these questions. So yeah, again we have two subdivisions. Let's work them one by one. Coming to the first subdivision, we have, in how many ways can 4 boys and 3 girls be seated in a row so that, okay, be clear with the questions condition, so that no 2 girls sit together. Just be careful with the question. with the condition, especially the condition, no two girls are sitting together. So what do you mean by that? No two girls are together. So the meaning here is they're coming to deliver that no two girls are together means if you see any two girls, they should not be sitting next to each other. This is going to be the condition. Okay, that means definitely between two girls there should be at least one boy sitting. This is the condition they are coming to say here. Okay, all right, yes. So in this way, if you want to make these people seated, in how many ways can this arrangement be done? This is going to be the question. Okay, and see here how many boys, how many girls are here? There are 4 boys and 3 girls. Okay, all right, yes. Now how to handle this kind of question is, just listen very carefully and see the condition. They are specifying that no two girls are together. This is what they are coming to specify. Okay, all right. So in this case, what we are supposed to do is, let us just work it bit technically. Okay, what we have to do is, we will first try to arrange the boys. We'll arrange the boys first, then we will go to the girls arrangement. Okay, since girls should not be sitting together, they are asking no two girls should sit together, we will first go for boys first. Okay, fine. How many boys are here? There are 4 boys. Okay, then do a simple thing, just make 4 empty slots. Okay, make 4 slots. Okay, 1, 2, 3 and 4. Okay, and also you see that you have got enough space between the boys slots. Okay, don't make them very closer, have some enough space. Okay, because I have a reason, so for that just make the 4 boys like this. Okay, so that means this 4 boys we will make them seated first. All right, okay. Now this 4 boys can be seated in how many different ways? We made 4 slots here, and in how many ways can we make them seated? Very simple. We can just simply make them seated in 4 into 3 into 2 into 1 ways. That's it. So for boys we have got how many ways? So boys we will have 4 into 3 into 2 into 1. That is 4 factorial ways. Simple. That's it. Very simple. Okay. And now when you come to girls, for girls, how many ways we have to think? Okay, and for girls is what we have this important condition. No two girls should sit together. That's what they have insisted. Okay, now the reason why I made some gaps here is, now here in this gap only we are making, we should make the girls to sit. That's why. Okay, yes. Now see here how many gaps are here. You can just see it here. You can even take the extreme positions also. Okay, fine. Yes. Now I will just put arrows like this. Okay, 1, 2, 3, 4 and then 5. Are you clear with this? Now wherever I made the up arrow marks, in those 5 places are what I can make those girls to sit. I hope I can understand now. Now what happens is, in any of these slots, if you make the girls to be seated, definitely no two girls will be together. Is it or not? Fine. Yes, you can even examine and see that. Okay, if you make the girls to sit here, here, so basically like just for instance here and here, definitely there will be a boy between them, between these 2 girls. Correct? Yes. And same way, if you make girls like here and here, now what happens? One girl here, the other girl here. Now what happens is, there will be 2 boys in between. Is it or not? So that means there will be no possibility of 2 girls sitting together here. That is the reason we first made the boys to sit, and then later we are making the girls to sit. Okay, all right. I hope you can understand this. Now we will go for the girls possibilities. Okay, how many ways the girls can be arranged? That we will calculate now. Okay, so to make the girls, number of ways for girls, now what we can do is, the girls should be selecting the slots. Now the slots are the X's. Now the girls will be selecting the slots. Okay. Now how many girls are there? There are 3 girls there. Correct. Now the first girl comes. Now the first girl can be seated in how many different ways? The first girl has got, remember, see the slots very clearly. The first girl has got how many different slots? 1, 2, 3, 4, 5. The first girl can choose any one of these 5 slots. Correct. So that means the first girl has got 5 ways into. Now what about the second girl? Second girl will have the remaining 4 chairs. Okay. 4 ways, and third girl will have the remaining 3 ways. So 3 ways. That's it. Okay. So that means now if you calculate the overall answer, you will be able to get the answer. Okay. So the total number of ways is going to be what? So we can just multiply this, because for each of these 4 factorial ways, we have got these many ways to arrange the girls. Okay. So 4 factorial, this is going to be 24 into what about this calculation, 5 into 4 into 3, so this will give you 60, right? So this will be 60, so 24 into 60, the overall answer is going to be 144, 0, that is 1440 is going to be the answer for your first question. Okay, I hope you can understand this, right? So whenever you have no two girls or no two boys or no two objects to be together, this is the approach we have to handle. Okay, all right, now you understood this. The same way we will try to work out the second subdivision also. Here the question is, find the number of ways in which 5 boys and 5 girls can be seated. Okay, here we have 5 boys, 5 girls can be seated in a row so that no two boys are together. Here the condition is no two boys are together. Fine. Okay, so when you have no two boys are together, I hope you would have guessed what we need to do here. So here, what is the first task we need to perform? We have to arrange the girls first here. Like here the condition was no two girls are together, we went for the boys first. Same way here the condition says no two boys are together, for which you have to arrange the girls first. Okay, so how many girls are there? There are 5 girls there, right? So 1 2 3 4 5, just put 5 slots. Okay, these slots are for the girls. Okay, all right, clearly understand it. Okay, so first we will arrange the girls first. Okay, for girls how many ways it will be there? It will be 5 into 4 into 3 into 2 into 1, very simple, that is 5 factorial. 5 factorial is going to be 120. I'll write it now itself. So for girls there are 120 ways. And what about boys? So for boys, how many ways you will be having? And where can be the boys seated? We'll just place arrow marks here. Okay, boys can occupy these arrow slots. Wherever arrow is placed, in those places, thus boys can be seated. Okay, that means how many boys are here? There are 5 boys are here, right? So each of those boys can be seated in any of the arrow mark slots. Okay, so now the boys should be making the slots, is it or not? Should be selecting the slots. So in that case, what happens is the first boy comes, the first boy can choose any one of these. How many slots are there? Just count and see how many slots are there. Here how many slots were there? Here there are 5 slots, so we went for 5 into 4 into 3. And here there are how many slots? 1 2 3 4 5 6, there are 6 slots. So that means the first boy comes, the first boy can choose any one of those 6 slots. So 6 into, what about the second boy? Second boy can choose any one of those remaining 5. Third boy 4, fourth boy 3, and fifth boy 2 ways. That's it. Okay, so that means this will give you the answer to be how much? So this is how much? This will be actually 720, is it or not? So 720, so that means your overall answer, the total ways, the total number of ways is going to be, we can just multiply this 120 into 720 and that will give you the answer. So what is 120 into 720? I think I can use this space. So 12 into 72, I will just perform 12 into 72. 2 2s are 4. Next I will have 8 2s are 16, 1. And next I will have 7, 8. So we will have 864 followed by 00. Yes, is it or not? So maybe if you want, you can even check it. 720, 144, 864. Yes, yes, yes. So 120 into 720, 86400 is going to be the answer for this second question, second subdivision. Okay, so I hope you are able to understand the problem very clearly. So whenever you get this kind of condition, no two boys, no two girls together, so arrange the other group first, then you come for the remaining, the leftover slots. Wherever the gap is there, that gap you can fill the group where which is asked in the question that they should not be together. Okay, I hope you are able to understand this concept using these two examples. Okay, so you follow this, you can easily get the answer. And yeah, these are going to be the answers for your question number 14. Going to question number 15. Here we have, how many arrangements can be formed by the letters of the word vowels if we have got 5 subdivisions? All of them are going to be much easy questions only. So let's work them quickly one by one. Okay, so our given word is vowels. Okay, so this letters of the word vowels are to be rearranged based on the given conditions in each subdivision. This is what we need to do here. So coming to the first subdivision, if there is no restriction, without any restriction, if we need to arrange these letters, in what ways, in how many ways we can arrange, that's all. Okay, so if there is no restriction, that means what? We have got clearly 6 slots, 1 2 3 4 5 6 slots, 6 letters we have to place. So we will have 6 5 4 3 2 1 ways. That means the answer is going to be 6 factorial, which is 720. That's it. This is going to be the answer for your first subdivision. Very clear, right? And that too, be clear here, our letters are not repeated in the word, right? Okay, each letter is going to be distinct. Letters are distinct, so there's no repetition. So 6 letters, 6 slots. So 6 factorial ways. Answer is 720 is going to be the answer for your first subdivision. Coming to the second subdivision, here we have each word begins with S. So when you try to rearrange the letters, each of those words must start with the letter S. This is what the question asks. So that means again we will make 6 slots. Okay, 1, 2, 3, 4, 5, 6. We made 6 slots here, and here the condition is the word should start with the letter S. So that means the starting letter is S. That means this position we cannot touch hereafter. This is yes, that is fixed. But what can you tell about the other 5 slots? There are remaining 5 letters are there. Those 5 letters can be filled in this 5 slots in any different possible ways, different possible orders. So that means how many ways will be there? This means here you will have only 5 factorial ways. Okay, because of the reason you can't touch this other 5 letters, 5 slots, so 5 factorial ways. So the answer is going to be 120 is going to be the answer, because 5 factorial is 120, right? That's why. Okay, and yes, the same way you can even answer the third subdivision. Each word begins with S and ends with E. So that means 1, 2, 3, 4, 5, 6. So your starting letter should be S and ending letter should be E. This is what they are given here. So that means starting and ending slots are filled. No, you have no changes there, they are fixed, right? Okay, so you can't touch those 2 positions, but other remaining slots you can make arrangements. Okay, other remaining, there are 4 letters are there, 4 slots are there, so that means that will be 4 factorial, so which is 24 is the answer. I hope we can understand this also. And yes, last 2 are very important. Fourth subdivision says all vowels come together. I mean the vowels in the letter, the vowels in the word vowels, it should be together. That is what they are coming to say. Okay, our word is vowels, and in the vowels we have to make, or we have to collect the vowel letters together. Okay, basically if you see what are the vowel letters available here, the vowel letters available are O and E, and the consonants available are, the other letters are going to be consonants like V, W, L, S. They are going to be consonants. Okay, so that means this fourth subdivision says the vowels should be together. So that means we will make the vowels as one single bunch. I hope you understand. Since the vowels are together, I am collecting the vowel letters, they are coming together. Okay, so O and E are put together. And what about the other letters? Other letters are V, W, L and S. Okay, there is no restriction for those letters. So we have simply O and E alone coming together, and the other 4 letters are without any condition. Okay, that means here our task is like arranging how many different objects? 5 objects. That's it. Why? Because 1, 2, 3, 4 and 5. Because you made this as one single bunch, this is like one object now. So there are 5 objects. So to arrange 5 objects, there will be 5 factorial ways. But our problem is still not over. 5 factorial is for these 5 objects. But inside this bunch, vowels bunch, you have 2 letters. Those 2 letters can be rearranged in another 2 factorial ways. So for each of these 5 factorial ways, you have got 2 factorial ways. So your overall answer is going to be 5 factorial into 2 factorial, which is going to be 120 into 2, which is going to be 240. I hope you understand this. Is it clear? Yeah, fine. Last one, all consonants come together. So the consonants should be together. Now what about consonants should be together? This time what happens is you will have the vowels free without any restrictions, but the consonant letters, what are the consonant letters? V, W, L, S. These consonant letters should come together, means make these 4 letters as one single bunch, so that you take them anywhere, they come as a one single bunch, one single object. Okay, now this is like one object and there are other 2 objects. Fine. Okay, all right. So that means here if you see, there are totally 3 objects available. Is it or not? 1, 2, 3 objects are there. Now you have to arrange 3 objects, for which you have got 3 factorial into, hold on, 3 factorial for these 3 objects. So 3 factorial into what will come? Yeah, you would have got it. So you will have another 4 factorial ways. Is it or not? Why? The reason is very simple. Why? Because you know that these 4 consonant letters are there. Within themselves, they can be arranged in 4 factorial ways. For that is what we have this extra 4 factorial. So our overall answer is going to be 3 factorial, which is 6 into 4 factorial, which is 24. So our answer is 6 into 24, which is 144 is going to be your overall answer. I hope you are able to clearly understand this question also. Yes, so very beautiful question. So in one, we using one word itself, they have made different conditions. Okay, fine, all right. So yeah, now these are going to be the answers for your question number 15. We have question number 16 with us. Here, in how many ways can 8 boys and 7 girls can be photographed? if, so there are 8 boys and 7 girls, okay. So they are going to stand for they are going to be arranged for a photograph. If, so followed by, we have got 3 subdivisions. We are going to work all these 3 questions. They are going to be very easy only. So the first subdivision says 15 girls, the girls are to sit on chairs in a row and the boys stand in a row behind them. This is going to be the first condition we have here in the first subdivision. So that means those 7 girls are to be seated on the chairs, okay, in a row, straight row, okay. So that means we'll make a row of 7 chairs, okay, all right. So 1, 2, 3, 4, 5, 6, 7. This way, the 7 girls are made to be seated, and behind them, the boys are going to stand, okay. And for boys, we'll make 8 slots, okay, fine. 1, 2, 3, 4, 5, 6, 7, 8. So this way, we will make slots for boys. So that means this row, the girls will be seated, and this row, the boys will be seated. That's it. Very simple. Okay. Now for the girls, how many ways we can arrange the girls? Because these 7 seats are going to be occupied by the 7 girls only. So that means 7 girls, 7 seats. So that means here it is going to be 7 factorial. And now when it comes to boys, next boys. Here these 8 seats are going to be filled by, this 8 slots are going to be filled by the 8 boys only, for which you will have another 8 factorial ways. So for each of these 7 factorial ways, there will be 8 factorial ways. So your overall answer is going to be 7 factorial into 8 factorial. That's all. This is going to be the answer for your first subdivision question, okay. And if at all you try to expand this, you will get a very huge number to be the answer. So we will better leave this as it is. Coming to the second subdivision, here we have girls sit on even numbered chairs and boys sit on odd numbered chairs, and there are 15 chairs in a row. So here this question says, this subdivision says a condition, there are 15 chairs in a row, that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So in this way there are 15 chairs in one straight row, and here the girls are going to occupy the even numbered chairs. What about even numbered chairs? Even numbered means 2nd, 4th, 6th, 8th, 10th, 12th and then 14th. I hope you can understand this, okay. Now wherever I have made that up arrow slots, there girls will be seated and boys are seated on odd numbered chairs. This is what is given, okay, fine, yes. So that means here also if you see, in those arrow mark slots only we are going to make the girls to be seated. That means 7 chairs, exactly 7 chairs for girls and 7 girls are there. So that means in those particular 7 slots, if we need to arrange the 7 girls, there will be how many ways? 7 factorial ways to arrange the girls. And what about the other slots? Other slots are going to be obviously odd numbered chairs only, correct? If these are 2, 4, 6 and so on, the leftovers are what? 1, 3, 5, 7 and so on up to 15. Those chairs will be occupied by boys. So that means those 8 empty slots are going to be arranged. That is going to be filled by those 8 boys only. So 8 seats, 8 boys. Those 8 chairs can be filled in how many ways? Another 8 factorial ways. So your overall answer is going to be 7 factorial into 8 factorial. Again, you happen to get the same answer what you got here. Fine, yes. So even though the conditions are a little bit different, the answers are going to be same only, okay, almost the same. Yes, they are going to be exactly the same answers only. Yeah, next, last one, third subdivision. There are 15 chairs in a row and there's no restriction at all. That's it, okay. That is, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There are 15 chairs. And here there is no restriction at all. That means we can arrange the girls and boys in whatever way we want. That's it, okay. That means now come here. Here the first slot. Here what we can do? Here this slot can be filled by either a boy or a girl. That means any one of those 15 can come here. Now when you come to the second one, this can be filled by any one of the remaining 14 people. This one, any one of the 13 people. Then 12, 11, 10, 9, 8, 7. 6, 5, 4, 3, 2, 1 up to this 15 to 1. So you will have these many number of ways, which will be nothing but what? That's nothing but 15 factorial. So 15 factorial is going to be the answer for this third subdivision. Yes, okay. So a very easy question only with different conditions. So these are going to be the answers for your question number 16. Now coming to question number 17, here again we have got two subdivisions. Let's work them one by one. First subdivision we have, how many odd numbers greater than 80,000 can be formed using the digits 2, 3, 4, 5 and 8 if each digit is used only once in a number? This is going to be the question. So the digits we can use are going to be what? What are the given digits here? We can use the digits 2, 3, 4, 5 and 8. So there are totally 5 digits available, right? So using these 5 digits we need to construct numbers. And in what way we have to construct? Be clear with the question. They are asking us to construct odd numbers greater than 80,000. So that is, we have got 5 digits here, and using these digits we need to form numbers which are greater than 80,000. Okay, fine, yes. And that too, see the last part of the question, we are asked to form numbers in such a way that the digits, each digit is used only once in a number. That means what? The repetition of digits is not allowed. We cannot repeat the digits, okay. So that means we can use these 5 digits and you can use them only one at a time, and also our numbers should be more than 80,000. So that means what kind of numbers we can form? We can form numbers with 5 digits only, is it or not? Fine, yes. Already there are 5 digits, and since our numbers should be more than 80,000, we cannot form 4-digit numbers or 3-digit numbers, 2-digit, 1-digit numbers. They are not possible, and we can definitely form only 5-digit numbers. So just make 5 slots here, and now we will see how many ways in which we can do this process. Okay, all right, yeah, fine. So we have made 5 digits here, and now we will start from this first slot. Okay, all right, yes. Now see here, this is the first slot, and this one, in terms of these numbers, this stand for which place? See, this is the ones place of our number. This is tens, hundreds, thousands and 10,000s. So now this slot consists of the digit that will represent the 10,000s place. Is it or not? Fine. Now just think of what digit we can place here. Can you place any of these digits? Which possible digits we can place here? That we will think. Okay. Is it possible for us to place this 2 here? Just think and see. Just if at all you place this 2 here, what happens is our number will be of the form what? 20,000s. Is it or not? Yes. And if at all we place 3 here, our number will be of the form 30,000 and something. So is it possible? See, 20,000, 30,000, this way we cannot form numbers because of the condition given there in the question that we have to form numbers which are greater than 80,000. So that means here this digit can only be filled with what digit? This can be filled only with the digit 8. Is it or not? So that means I can fill this digit only with the digit 8 which is given there. Okay. Only when our number will be of the form some 80,000 and something. So that means our number will be greater than, obviously greater than 80,000. So that means this slot can be filled only with the digit 8. Do you understand this? So for that reason, don't put 8 here. It is wrong. Okay. So what we have to put here? So that means this slot can be filled in only one possible way. So this is formed in, or this can be filled in only one possible way. So just put 1 here. That is, this will be filled in one way. That one way is I can fill this 8 alone. That's it. Okay. That means we can fill this digit in one way. And that means this 8 is gone. We have got the other 4 digits. Now point number 2. Next is come to this place. Now what you can tell about this place here? So this place, what about this one? This is the units place. Again, go back to the question. Our question's condition says how many odd numbers? Odd numbers greater than 80,000. So the greater than 80,000 with which we satisfied this. Odd numbers. They are asking us to form odd numbers. So that means definitely this digit has to be an odd digit only. Or the digit we are going to fill here should be an odd digit only. Why? Because to make a number odd number, our last unit digit must be an odd digit. Correct? Is it or not? That's a condition, right? So it means here we can fill only an odd digit here. So now again see the list. What are the possibilities for odd digit here? So we can have this 3 coming here, or we can have this 5 here. So that means this digit can be filled in how many ways? Either this 3 or 5 can come. So that means we can fill this digit in 2 ways. I hope you can understand this. Okay. For the condition our number has to be more than 80,000, I can fill this digit, this first digit only with only one way. Only with this 8 I can fill this. Okay, so only one way for filling this digit, and there are 2 ways because this is an odd number, odd digit. To make it an odd digit, I have to fill with this one with either 3 or 5. So 2 ways for this digit. So hereafter there is no restriction at all. Okay. So one digit, this is formed, this is over, this is filled, and any of one of these 2 digits will come here. So here 2 ways. And what about the other 3 slots? Hereafter there is no restriction at all. Now how many more digits will be remaining? There will be 3 more digits remaining. Is it or not? Because we have already placed 8 here. And one among these 3 or 5 will be already placed here, and there will be other 3 digits. So that means this can be filled in 3 ways, and this one can be filled in just one of them will be placed. This one 2 ways, and again this one, the last one, this can be filled in 1 ways. So it means the total number of numbers, odd numbers greater than 80,000 we can form is, when you just calculate it, this will be able to get the answer. Okay, so shall we calculate and get the answer? The answer will be 3 2s are 6, 6 2s are 12. So that means only 12 numbers we can form based on this given condition. Okay, yes, fine, all right. So that means 12 is going to be the answer for this question. I hope you are clear with this. Yeah, we have got another similar question here. Let's try this question also. Second subdivision, how many numbers greater than 20,000 can be formed using the digits 0, 1, 2, 3 and 4. Okay, 0, 1, 2, 3 and 4. Let's note it. 0, 1, 2, 3 and 4 with no digits being repeated. Okay, that means the digits are not allowed to repeat. This is going to be the question. So here again we have to form numbers which are greater than 20,000. Okay, greater than 20,000 means again our number has to be, it has to be a 5-digit number. Is it or not? We can form a 5-digit number only. 1, 2, 3, 4, 5. Why? Because we have 5 digits and we can use all the digits only once without repetition, and our number has to be more than 20,000. So we can form 5-digit numbers. That is okay, fine, accepted. And here we have to do it in a similar way. How many ways we can fill it, each of these slots? Okay, fine, all right, yes. Now again let us start from this place, this first digit. Okay, so again this stands for the 10,000s place only, and since our number should be more than 20,000, just think of this digit can be filled in how many possible ways? Can we have a 0 here? Obviously 0 cannot come here because it won't make our number to be a 5-digit number. Can you have 1 here? If you have 1 here means what happens? This number will become 10,000 and something. Is it or not? Yes, 10,000 plus. But what about the other digits? We can either have 2 here or 3 or 4. So any of these 2, 3 or 4 can come here. Definitely they can come here. Is it or not? Any one of them can come here. Why? Because if you placed 2 or 3 or 4, then definitely the number formed so far will be definitely greater than 20,000. That is the reason. Okay, so that means this digit can be filled with any one of these 2, 3 or 4. So it means we have got 3 ways to fill this first digit. And hereafter, is there any restriction like odd numbers or even numbers? Here for the first subdivision we had a condition odd numbers, but here we don't have the condition like the number forming should be an odd number or even number. So that means hereafter there is no restriction at all. We can fill any of these digits with any of the remaining digits. That's it. Okay, fine, yes. Now how many more remaining digits are there? So one digit is already placed. There are 3 ways, but still any one of them would have been filled here. So there are how many more digits remaining? There are 4 more digits remaining. Hereafter there is no restriction at all. So this digit can be filled in 4 ways. This one 3 ways, 2 ways and 1 way. So that means overall our answer will be equal to what? So 3 into 4 into 3 into 2 into 1. So the answer is going to be 24 3s are 72 is going to be the answer. Is it or not? So such an interesting question we got here. So 72 is going to be the answer for the second subdivision. Okay, I hope you are very clear with both the problems, the approach we took to solve them. So we have to be very clear with the conditions. That's what is very much important. So we should be clear with the conditions what they have posted, and based on the conditions we have to fill each of those digits. This is what is very much important. So yeah, you can take these questions also, and yes, these are going to be the answers for your question number 17. 18 is our next question. Another interesting one. A moped license plate has 2 letters and then 4 numbers in it. How many plates can be made without duplicating if there are no plates with the number 0? So there is a license plate for mopeds. So how they are framed is, you will be having 2 letters basically. Okay, there will be 2 letters and that will be followed by 4 digits. This is what they are coming to say there. So maybe for an example, our moped plate will be, the license plate will be looking like this, something like this. So maybe R then K, then we may have a number 1729, something like this, or it can be A B then 0513, something like this. Okay, So you will have 2 letters followed by 4 digits. This is how you have, okay. And our letters or numbers can even be repeated. Fine, okay. So what is the meaning of there is no duplication? What is the meaning of no duplication? Duplication means we should not have the same exact series of these letters and numbers for another plate, but we can have within the plate, we can have the letters or numbers, the digits that can be repeated. No issues with it. Okay, fine, all right. So for an example, we can even have it like this. So maybe for an example, yes, yes. Okay, the letters are repeated. Yes, yes, 7777. This way also we can have. Okay, no issues with it. So like this, they are going to form license plates. Okay, so by having 2 letters and 4 digits. But the only condition is if there are no plates with the number 0, they are coming to tell. What do you mean by that 0? 0 means all the 4 digits are 0. Only then your number will be 0. Is it or not? Fine, is it or not? So all 4 digits are 0. That only represents the number 0. That means this is not allowed. Okay, you cannot have this one to be a possible plate, number license plate. This is not allowed. But except this, all the other things are available. Okay, that we can take it for granted. Okay, this is what they're coming to say here in this question. So let us now handle this question in a very technical way to answer it. Okay, all right, yes, fine. So that means we have got what? We have got 2 letters. Okay, we have got letters and then digits. Okay, we'll work them separately. So first of all, letters are how many letters? There are 2 letters, and for digits there are 4 digits. Okay, all right, yes. So that means what we can do here is, first we'll come for the letters case. Okay, so letters, basically how many letters are there? There are 26 letters. Is it or not? So there are 26 letters. And when it comes to digits, how many digits are there? There are 10 digits. So letters we know A, B, C up to Z, and digits if you see, it is going to be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So these are going to be the 10 digits. So now letters, how many possible ways we can form, that we will think of. It's going to be very simple. So the first letter can be filled in 26 ways, the second one also in another 26 ways. Is it or not? Since we can even repeat the letters, there's no issues. So 26 into 26 ways we have got totally. Okay, so what about 26 into 26? It is going to be 26 square. Is it or not? So 26 square is 676. So let's note it here itself by hand. Okay, done. And yeah, coming to the digits now. So now what you can tell about the digits? How many ways we can form the digits? Digits we can form this one as 10 ways. Here another 10 ways, because the digits can also be repeated, right? So 10 ways, 10 ways, again 10 ways, again 10 ways. So totally how many 4 digits we can form? Totally if you see, there are totally how many ways? Totally there will be 10, 10, 10, 10. This will give you 10,000. So totally 10,000 4-digit numbers we can form. But except this possibility, except this 0, 0, 0, 0, everything is accepted. Okay, so that means only this one should be removed from this. So that means just this one possibility we will just eliminate from this. All the other remaining possibilities we can take. Okay, so now what will be your grand answer here? 10,000 minus 1, that will be nothing but 9,999. So that means the 4 digits we can form in how many possible ways? Totally 9,999 ways we can form. Okay, so that means letters there are 676 ways and numbers there are 9,999 ways. So now to get your overall answer, I mean the license plate is composed of, the plate is composed of letters as well as digits, right? So to get your overall total answer, we have to again multiply the 676 into 9,999. So this will give you the overall answer. Okay, so that means we have to multiply this. Okay, fine. So how you can multiply is, better we will multiply the same way. Okay, all right. So we can multiply the 676 into 10,000. Okay, 676 into 10,000 will give you 676 into 1, 2, 3, 4. Fine, yes. So this is what we will be getting for 676 into 10,000. Now from this we will minus 676 itself. We will minus 676, so that we can very easily get our answer. Okay, I hope you can understand this. Instead of multiplying 676 into 9999, I am just doing my calculation like this. Actually what I am coming to do here is 676 into 10,000 minus 676 into 1, because this will give you the answer for 676 into 9999, obviously, correct? That's the reason. So we will carefully do this calculation. So now I can take this as minus, I'll take this as 1000. Okay, so 1000 minus 676 will give you 324, if I am right. Yes, and because of I have borrowed this 60 becomes 59. and now as it is 9, this is 5, this is 7, this is 6. So your answer is going to be 6, 7, 5, 9, 3, 2, 4 is going to be your overall answer for this question. I hope you can understand this, right? Okay, so yeah, this is going to be the answer for your question number 18. Question number 19, another simple as well as an interesting question. In an examination, there are 3 multiple choice questions and each question has 4 choices. Fine, okay. So there are 3 multiple choice questions and for each question there are 4 choices. That means how will be the questions? You will have a question number 1. You will have the question followed by 4 options. Maybe we can name the options as A, B, C and then D. Okay, same way you will have the second question. Second question also you will have 4 choices, A, B, C, D, and again you will have the third question for which you will have again third question, again you will have the 4 choices. So this is how you are going to have those 3 multiple choice questions. Okay, and if a student is going to attend it, what happens? The student will take the first question, he will take any one of these 4 choices. Second one, he is going to attend any one of these 4, and third one, he is going to attend any one of the 4 choices. This is how the answers can be attended. Is it or not? Yes. Now we'll see the question. Find the number of ways in which a student can fail to get all correct answers. So now what do you mean by that? We should carefully understand, very clearly understand this part of the question. Okay. In how many ways a student can fail to get all correct answers? Now what do you mean by that? That means the student should not be attending all the 3 questions correctly. That's the meaning. Fine. Okay. So if at all I want to make it in clear words, this is what I can tell. Fine. Okay. Let me repeat it again for a clarity. The student should not attend all the 3 questions correctly. That means what is the meaning? He can give 2 questions correctly and he can leave 1 wrong. Or he can only give only 1 question correctly and he can attend the other 2 wrong. Okay. The other 2 means it can be any 2. Okay. Any one of these 1 questions he can attend it correctly. The other 2 he can give wrong. Okay, or he can do what? He can make it wrong for all the 3 questions. All 3 questions wrong answers. This way also it can be. Okay, fine. Yes. So this is what they are asking us to get here. Okay. So in how many ways can the student get not all of them correct? Not all correct. This is the question. So now how we can handle this problem is, so to find this answer, we will just do a simple thing. Now total number of possible ways, from this we will calculate, and from this value we will just minus all correct answers. All correct answers. That is, all the 3 questions he is going to attend it correctly. All 3 questions he is going to attend correctly. Okay, fine. Yes. So this we will calculate. Okay. First of all, total number of ways is what? There are how many questions? There are 3 questions. So make 3 slots, and each of these questions he has got how many ways to attend? He can answer the first question in how many ways? He can answer the first question in 4 ways. Second question again 4 ways. Third question again 4 ways. Is it or not? Because for each question there are 4 choices. The student can select any one of those 4. Is it or not? So for that reason 4, 4, 4. So this will give you the total number of ways in which he can attend all the 3 questions. Now from this minus, now what do you think about this possibility? All correct. In how many ways can he attend all the 3 questions correctly? That can be done in only one possible way. Correct, right? Why? Because all 3 are correct. He can attend it in only one way. Why? Because here there will be only one correct answer. Dash, dash, dash. Only one correct answer will be there for the first question. Only one correct answer for second. Only one correct answer for the third. So in only one possible way he can attend all of them correct. Okay. So that means what I can do is, now I will calculate this. This will be 4, 4, 4 will be 64 minus, here we have 1. So your final answer is going to be 63. So that means in 63 ways he can give the answers. He can attend the question paper in such a way that not all the 3 questions are correct. That's it. This is going to be the answer. Okay, fine. Yes, I hope you can understand this. So yeah, 63 is going to be the answer for your question number 19. Now we have question number 20, and this is going to be the last question of this exercise. Yeah, yes. There are 3 prizes to be distributed among 6 boys. So there are 3 prizes, and boys there are 6 boys. So these 3 prizes are going to those 6 boys. Fine, okay. But we may have some conditions. Let's continue the question. In how many ways this can be done? Okay, it can be done if Now we have three subdivisions followed here. Let's try to answer each of these questions very carefully. Okay. Coming to the first subdivision, if no boy gets more than one prize, this is the first subdivision we have here. So now what do you mean by this condition? No boy gets more than one prize means, the meaning is what? That means if a boy is getting one prize, that means the same boy should not be getting another prize. This is the meaning. Okay. So that means at a maximum a boy can get only one prize. This is the meaning. Okay. So that means be clear with the question's logic here. The prizes are going to the boys. So that means the prizes are going to have the slots. Okay, alright. So that means how many prizes are there? There are three prizes here, correct? So that means let us just make three slots here. 1, 2, 3. Fine, done. Okay, yes. Now this is for the first prize. This is the second prize and this is the third prize. We'll have it like this. Okay, maybe I'll put like this: first prize, this is second prize, and this is third prize. Now just imagine, just see, this first prize can be distributed in how many possible ways? You can tell that, right? There are 6 boys, correct? So that means this first prize can be given to any one of the 6 boys. So that means this has got 6 ways. And now what about the second prize? The second prize will have how many possible ways? Since a boy who got a prize already cannot again get another prize, what you can tell about the second prize? The second prize will have only 5 choices. Is it or not? Yes. The idea is very clear to you, right? The second prize will have only 5 choices because the first prize already went to one boy. So that means that boy is now out of the scene. Now when the second prize comes, that will be having only 5 choices. Okay, so 5 ways this can be distributed. And yes, coming to the third prize will have how many choices? So third prize, there will be 4 more boys. So 4 ways. So that means your answer for the first subdivision is going to be 6 into 5 into 4, which is going to be what? 120. Yes. Yes, that's answer, right? So 6 5s are 30, 34s are 120. So 120 is going to be the answer for your first subdivision. Yes. Now second subdivision is there is no restriction as to the number of prizes any boy gets. Okay, this is the question. So that means here there is no restriction at all. This is asking us to get the total number of possible cases. Total, no restriction at all. Okay, total ways, how many are there? This is going to be this question's meaning. So that means if there's no restriction, then that means what? The first prize, second prize, third prize. There's no condition. So the prizes can go to any boy it wants. Okay, fine. So it doesn't matter whether a boy already got a prize or not. It can be distributed in any possible way. So that is what is this second subdivision asks. So here what would be the number of ways for the first prize? First prize can go to any one of the 6 boys, right? So that means there are 6 ways in giving the first prize. And coming to the second prize, what about the second prize? Second prize again will have 6 possible ways, right? Because that again can be given to any one of those 6 boys, no matter whether a boy already got it or not. Again it can go to the same boy itself. So no restriction at all. So 6 ways for the second prize also, and again for third prize also another 6 ways. So 6 into 6 into 6, the answer is going to be what? It's going to be 6 cube, right? So 6 cube is 216. So 216 is going to be the answer for your second subdivision question. Okay, all right. Yeah. Now next, third subdivision, no boy gets all the prizes. This is what is really a little tricky for us to understand. Okay, we should carefully understand this question. So no boy gets all the prizes. Now what do you mean by this meaning? No boy gets all the prizes means the same boy should not be getting all the prizes. This is the meaning. Okay, there are 6 boys are there and not all the prizes are going to the same one single boy itself. This is the meaning. Okay, fine. Yes. So how you can get this one is, let's do a small trick. Since it is demanding for no boy gets all the prizes, we'll do it like this. Okay, we will take the total number of ways. From this we will minus. What if the boy gets all the prizes? What if each of the boys get all the prizes? Okay, each boy, okay, I'll write it clearly. Each boy gets all prizes. So now from this total, we will just minus the number of ways in which this can be done. Okay, fine. Yes, we know that the total is what? 6 into 6 into 6, which is 216 minus. Now think about this one. This can be very easily obtained. Each boy gets all the prizes. That is, either the first boy can get all the 3 prizes, or it can be like the second boy is getting all the 3 prizes, or either the third boy can get all the 3 prizes, or the fourth can get all, or the fifth can get all, or the sixth can get all. So that means this individual process alone can happen in 6 different ways. I hope you can understand this. Is it or not? Yes, is the point clear? Each boy is getting all the prizes. This is what we don't want. So that is the reason we are getting the total number of ways. From this we are just subtracting this 6 ways. I hope you also understood why it is 6. Because there are 6 boys there, individually seeing all boys, all prizes are going to one single boy itself. This is what, here it is specified here, right? Okay. So if I want to calculate the number of ways for this one, all prizes are going to one single boy itself. It can go to any one of those 6 boys. So that means in 6 ways this process can happen. So 216 total minus this 6 will give you the answer for the given question. So 216 minus 6 is exactly 210, and that is going to be the answer for your third subdivision. Okay, all right. Yes, I hope you are able to understand this also, and yes, successfully. This is going to be the answer for your question number 20 also. Yes, all of you, I hope now you are clear with the concepts that we saw here under this exercise 7.3. You are clear with the concepts, and also I believe that you are clear with the approach we handled to solve each of the problems under this exercise. And if at all you have any doubts, please post it in your comments. When I see it, I will see to rectify your doubts. Okay, all right. If you feel that this session was useful, please give a like. And also if you feel this session would help any of your friends, please do share this video to your friends also. And again, we'll catch up in the next session with some other interesting concept solving or solution solving, exercise solving videos. See you soon there. Thank you so much.